Alright, so this is for review, or if you were absent, the metric notes that we took in class. So to get yourself going, draw this on a piece of paper. Kind of draw it in the center of the paper like I have it on here, because we're going to be writing stuff above it, below it. Okay? So pause the video so that you can get that done before I start moving on. So this is what is called the metric staircase. Alright? We need to fill in some more information, but first off, let's figure out what base means. Alright, so in the metric, base is what we consider 1. It's kind of like our starting unit that we define all the other units on. Alright, so for length, the base unit, hopefully you remember this, is meter. And this is not writing right. Okay, for mass, base unit is gram. For volume, base unit is a liter. And last one we'll throw on here is time. We deal with seconds. Alright, now all of these units have abbreviations. So meter is abbreviated lowercase m, mass is abbreviated with a gram or G, liter is abbreviated most commonly with a capital L, and time is with a lowercase s. Okay? So, if you don't remember how to fill out the rest, one easy way to remember that is King Henry died by drinking chocolate milk. Okay? So, if you can remember that sentence, then that should help you fill in all the other prefixes that we use to define other metric units. Alright, so king is for kilo. And then Henry is for hecto. Sorry, my thing does not want to write today. Hecto. The first D is for deca. With an E in there. That just doesn't want to show up. The second, then B, bi is base. And then our next D is deci. And then we have centi and milli. Okay? So, the nice thing about the metric system, and what makes it really easy to convert between these different units, is because every step is either 10 times bigger or 10 times smaller. Okay, so going up the stairs, the unit gets 10 times bigger, right? So a deca is 10 meters, like a decameter is 10 meters, or a hectometer would be 100 meters, or a kilometer would be 1,000 meters. Okay? Whereas if you go down, then these things become less than a meter. So decimeter is 1/10 of a meter, a centimeter is 1/100th of a meter, and a millimeter is 1,000th of a meter. Okay? So, how these work is a kilometer. You're sitting there and taking that prefix, kilo, and attaching it to meter. You can also have a kilogram, or a kiloliter, or a kilosecond. Okay? To also address the abbreviation portion, whenever we abbreviate those kind of the non-base units, they will always have two letters. The letter that matches the prefix and then the letter that matches the base unit that we're talking about. Okay, so kilo is abbreviated K, hecto is abbreviated H, deca has to be a capital D because deci is lowercase d. Alright, centi is lowercase c, and milli is lowercase m. Alright, these abbreviations on the prefixes cannot show up alone. They have to be attached to a base abbreviation. Alright? Only the base units, MG, L, S, can be on their own. Alright? So, let's talk about moving along the staircase. I want you to think about a meter stick. Alright? The meter stick has lots of little tick marks on it. Alright? The bigger ones correlate to centimeters, the teeny tiny ones correlate to millimeters. Okay? So what I want you to do is think about if you were converting up the staircase from centimeter to meter. Alright? So say we have 10 centimeters. And we want to know how long that is in meters. So think about your meter stick and where 10 centimeters would fall on it. Do we have a whole meter or do we have a portion of a meter? Hopefully you're saying a portion of a meter. So what that means is that our number has to get less than 1, which means it has to be smaller than 10. Right? So if you're going up the staircase, your number must get smaller. Alright? So, another thing to think about is, say, 3.7. Because everything on the metric staircase is moving by tens, every step moves the decimal point, either to the left or the right. So think about which direction moving the decimal is going to make our number get smaller. Right? If you move it to the right, the number becomes 37. If you move it to the left, the number becomes 0.37. Alright? So if you're going up the staircase, your decimal goes left. Alright? Now conversely, let's talk about this direction, going down the staircase. So let's say we're going from 1 meter, centimeters. Okay? So think about it, we've got 1 whole meter. Is that made up of many centimeters, like more than 1? Or is it made up of a partial, less than 1 centimeter? Right? If you think about all the tick marks on the ruler, you know there's more than 1 centimeter. Right? So if you're going down the staircase, your number must get bigger. Alright? And if you think about your decimals again, which direction made it 37? Alright? Moving the decimal to the right. So if you're going down the staircase, your decimal goes right. Okay? So let me shrink that down a little bit so we can still see it, but let's do a couple of practice things. Alright? So let's say you want to know how many say we have 37 dm and we want to find out how many mm that is. So think about it for a second. What do these mean? What does lowercase d as a prefix stand for? You should be saying deci. And then what does the base unit m stand for? Meter. Right? And what about mm? That's a millimeter. Okay? So we are going from deci, which is right here, to milli, which which is right here, right? You don't need to count the step you start on, so you're actually going to take 2 steps, right? And we're going down the staircase, which means our decimal goes which direction? To the right. Okay. Now, where is your decimal on this number? I hope you are saying after the 7, or always to the right of the number. If you don't see the decimal, it always falls at the end of the number. Okay? So then we're going to move this decimal to the right twice. And what do I fill the holes in with? Hopefully you're saying a 0. So that's going to be 3,700 millimeters. Okay? Let's try another one. Let's go from 0.5 meters. Let's not use length again. Let's use different unit. 0.5 grams equal to Hg. So Hg is going to be hectograms. Okay, so we are starting at our base because that's where plain grams shows up. We're going to hectograms. Alright, again, you don't need to count the stair that you're on, so you're going 1, 2 steps, and this time we're going up, which means our decimal has to go to the left. Alright, so 0.5, 1, 2, there's our decimal, and we fill in zeros. Yep. Do not need that 0. Okay, so it's 0.005 hectograms. Alright, you will see me write this way. I will always throw a 0 in front of the decimal point. The reason why I do that is because it makes the decimal point a little more obvious. Alright, because the only time that you have a 0 in front of numbers is when you're dealing with decimals. Alright, so just recognize that. That 0 didn't count in the 2 zeros from moving our decimals. It's in front of the decimal, so that wasn't one of the extra zeros that I was adding to our number. Alright, that 0 is just kind of like a placeholder. Alright, let's try one more. Let's go from 0.75 KS to CS. Alright, KS should be kiloseconds, CS should be centiseconds. Okay, so we are going from kilo, so up here, down to centi. So we're going 1, 2, 3, 4, 5 steps, and since we're going down, the decimal goes to the right. Alright, 1, 2, 3, 4, 5, 1, 2, 3, that makes 75,000 centiseconds. Okay? So, there's no online quiz to go with this one. There is, however, these 5 problems that I want you to do in class. We will be using Canvas to practice the quiz feature by answering these. Alright, this also will get you a stamp. So, see you in class.